again, it's Mr. Santana just going over how to subtract numbers written in scientific notation. And as you can see here, our example, we're going to go over that briefly, okay? So as with addition, when you are subtracting numbers written in scientific notation, you definitely want to have the same exponent. And just to be clear, this number and this number have to match. So that is definitely what we're looking for. So what we're going to do is we're going to try and match the highest exponent. So in this case, -3 is actually larger than -5. So we want to match that. Okay, and in order to get there, we have to add 2 units to the -5. So let's briefly look at that very quickly over here. 2.309 times 10 to the -5. Ooh, that shouldn't have happened. There you go. Okay, and what we're going to end up doing here is, like I said, increasing -5 by 2 to get -3. So since that's happening, we're going up on that end. We have to go down on this end, and that means we're going to move the decimal 2 places over. So I have to include a 0 here and here so that I can write my decimal right there. So you end up with 0.02309 times 10 to the -3. Okay, so now we have to use this number in our calculation, and I'm going to actually reverse this because I need to use the commutative property. 4.91 is a bigger number than 0.02309, so it's going to make it easier to calculate, but I'm going to keep the negative with the 4.91. Very important that we acknowledge that. So let me write this first. And you're probably wondering, why didn't I just finish that number? I'm going to. What I need is definitely to have some placeholders. And I just want to highlight that that's exactly what I'm doing. So 9 goes with 0, 1 goes with 2. This 0 that I'm including goes with 3, this 0 that I'm including goes with the 0, and this 0 that I'm including goes with the 9. So it's important to note that it's okay to do that when you have decimal numbers. It does not change the value of the number. Alright, so like before, you're going to keep the common factor here, which is 10 to the -3. That stays with you. Alright, so at the end of this, I know that my number is going to be negative because 4.91 is or has a larger absolute value than 0.023. So I'm actually going to end up subtracting because they're both differing signs. So you have a negative plus a positive, and that is going to end up as a negative because the negative number has the greatest absolute value. So now I kind of have to borrow a little bit. So let's set the stage. I need to borrow from here. This becomes a 0. So this then becomes a 10. But I need to borrow for the other number. So this is going to become a 9. This becomes a 10. But I need more over there on the right as well. So I'm going to borrow from here. This now becomes a 9. And this becomes a 10. So a lot of this is going to be easy. I know that I'm going to end up borrowing from that 9 over here, but we'll get to that in a moment, right? So 10 minus 9 is 1. 9 minus 0 is 9. 9 minus 3 is 6. And as I was saying before, 0 take away 2 can't be done, so I have to borrow from here. Cross this out. This becomes an 8, and this becomes a 10. So back over here, 10 take away 2 is 8. 8 take away nothing is 8. Then we have the decimal, and 4 take away nothing is 4. So that minus symbol is all the way down here. Is very uncomfortable. It should be more there. All right, so this is what you end up with is 4.88691 times 10 to the negative 3 with the negative in front of the 4. So this is the answer in scientific notation. And if you were writing it in standard notation, this is going to be a decimal because of the negative in front of the exponent. So that means that the decimal goes to the right. I'm sorry, to the left. So 4 is the first number, but the decimal would be to the right of that. So I'm going to go 1, 2, 3. It's going that way. So there has to be a 0 here in this jump, a 0 here in this jump, and a 0 out here to be the two zeros that sandwich the decimal, so to speak. And then I can write the other number. So 8, 8, 6, 9, 1 is the answer in standard notation. All right.